like I said, there are three things that are happening: the good, the bad, the ugly. And I'll kind of go through these one by one and hopefully try to drag your attention and your value system towards the first part, the good part. So what's happening within the world of human kinematic studies and healthcare? So we saw this revolution that happened in computer vision because of ImageNet trained models being deployed and conquering a lot of these vision-based domains. So similarly, if you have like the equivalent of ImageNet like GateNet, can we go and solve problems? So yes, it has been solved in three different domains: neurodegenerative disease treatment, geriatric care, and gait and posture. So with regards to gait and posture, you have peer-reviewed papers that talk about, basically being able to categorize abnormalities of gait. They have actually showcased how, Android-based sensors are actually as accurate as the commercial medical grade sensors that are used in these studies. So these need to be, there's clearly a market for you to package these in the form of a commercial product. There is a lot of work on anticipatory postural adjustments using commercial smartphones. Similarly, using gyroscope for basically quantifying reduced arm swings in hemiplegic gait, a lot of work being done there. So these are all, extremely interesting applications in the medical domain, where you're basically using gait analysis in the same flavor of algorithms to solve more important and pressing problems. With regards to geriatric care, one big issue is fault detection by the elderly. You can do this very easily using accelerometers and gyroscopes. The fragility detection and granular classification can happen, by using the same flavor of algorithms. The timed up and go test is another telltale case where the patient doesn't have to kind of go to the hospital. They can do this in the comfort of their own home. And also when it comes to neurodegenerative disease, diagnosis, so many papers have been published demonstrating brilliant results with regards to tracking of the the denigration of the symptoms with regards to Parkinson's disease, especially recognizing signs of rigidity in muscular motion, with regards to tremor classification, with regards to gait variability because of Parkinson's. There are apps within the domain of human kinematic studies that have demonstrated this for disease management. And here is a snapshot of all of the brilliant things that are happening within this domain. The only thing that needs to be done is you take your large deep learning models that have been trained on large gait data sets and just transfer learn into these awesome domains where amazing things are happening. What about the bad facets? Well, like I said, we are making really poor decisions as a community while enabling the surveillance facet of things, where you're not trying to solve the problem of re-identification, but you're trying to solve the problem of just identification in a large database. And this video that kind of went viral on YouTube some time back, where this company claims 96% accuracy on, I don't know how large of a set, it is clearly meant for state-sponsored surveillance. It's really, really disappointing that even academia seems to kind of feed into this. So please, 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 go through a soul searching if you're working on these specific facets. And the perfect storm is brewing now. There's a lowering cost of surveillance cameras, growth in attention-based architectures and better models, larger and larger training data sets, tremendous growth with regards to model compression techniques, reduced cost of cloud storage, and lack of ethics in the field in general. So, we are kind of in a slippery slope situation. And hopefully the thought leadership with, places like IGCB will help in kind of, course correction in this regard. The ugly, of course, you have some very unfortunate papers which are replicating the horrors of physiognomy and stuff like that, where this paper claims that they can kind of detect if a person is being deceptive just on the basis of gait and gesture. Think papers on emotion detection and so-called, emotional state analysis using gait, gender classification, so many papers that have absolutely no ethical grounds to stand on or scientific grounds to stand down. And these people, and there's a tremendous body of literature in computer vision that have kind of clearly enunciated the pitfalls of doing this, how the most minoritized groups are being victimized. And I'm really hoping that the community will kind of come together. The three good reads that I would like to suggest in this regard are Ruha Benjamin's Race After Technology, Sophia Noble's Algorithms of Oppression, and Shoshana Zuboff's The Age of Surveillance Capitalism. Hopefully, all of you working in gait analysis will pay heed to the voices of these strong scholars and understand what you might be doing might actually have deeply stark ethical ramifications. So on the conclusion, you have like a lot of applications with regards to transfer learning happening with regards to human kinematics analysis. Please focus on, if you're going to be doing biometrics, please focus on re-identification problem that is authentication and not surveillance. Please ensure that all the data you collect and the technology you're being deployed is consensual. Consent is necessary, it's not sufficient. In fact, in yesterday's BBC article, there's a beautiful statement that says consent does not work when there's an imbalance of power between controllers and data subjects, such as the one observed in citizen-state relationships. Pay heed to these, pay heed to what the privacy researchers are saying. Emotion classification as it stands is a pseudoscience. Please don't pursue problems in that domain. Gender classification is ignorant and harmful. Please do a soul searching if you're actually working on that for your doctoral thesis, no worse. And like I said, I had these 20 checklists. Basically make sure that you're kind of going through and ticking all of these boxes before implementing this in the real world. And with that, I would like to conclude my session. And yeah, thank you so very much for being patient. I will kind of leave the previous slide on so that this will kind of be like a, my parting statement as such.
Great.